In chapters 1 and 2, we use the idea of simulations to help us kind of estimate the likelihood that an event occurred by random chance, or what we called sometimes just by luck. And the reason that we did this is because we could reach conclusions then about whether we thought random chance was a good explanation or a good fit for why a particular event occurred. So in each simulation problem, we came up with the likelihood, and it was represented by this value over here at the right. We would often measure something like, hey, well, what are the chances of getting something like 23 or greater? And the simulation applet showed us this value. Well, in chapter 3, what we want to try to look at is how do we actually exactly calculate the probability of a particular event occurring by random chance? Because what you may have noticed as you practiced ideas throughout chapters 1 and 2 with simulations is that this red number was not always the same every time you ran a simulation. Maybe you ran one and you looked at my answers where I ran one and they didn't match perfectly. And of course, that's totally reasonable because you looked at a certain number of repetitions of a particular event, and I looked at another set of repetitions. So it's almost kind of like if I flipped a coin 10 times and you flipped a coin 10 times, we don't always expect to get the same outcome. But we can still maybe see general patterns. Well, what makes then simulations a bit hard is what do I do when I get close to that kind of 5% cutoff line, where we said that if something happened under 5% of the time, that random chance wouldn't be a good explanation for why it happens. And if something happened over 5% of the time, random chance could be a good explanation. Well, what happens though if I get something that's really close to that 5% line and I know that my red value here might not be perfectly accurate? This is why it might be helpful to be able to try to compute the exact probability, the exact likelihood of an event occurring by random chance. And so this is really going to be our goal throughout chapters 3, 4, 5, and 6 is how do I determine the chances of something happening? Now to get started on this, we're going to have to highlight a couple key definitions and pieces of terminology to really help us kind of set the stage for how we do this. So let's take a look here at our first two definitions. The first one here is going to be what we call sample space. The sample space of an experiment is going to be the set or the list of all of the different possible outcomes of the experiment, all the things that could ever happen. Those create the sample space. So if I was thinking about like flipping a coin, the only things that could ever happen as a result when I flip it is I get heads or I get tails. So my sample space would simply be heads or tails. Now, if I change the experiment, I can maybe have a sample space with more items or even less items. An outcome is just one single result of a probability experiment, like flipping a coin. So we're going to take a look down here at something like example 1. We're going to consider an experiment of spinning a spinner that contains 6 different color choices. Now, you can actually find a link for the spinner that I'm going to be pulling up here in just a second at the following web address. And so you could go ahead and try to work through this on your own as well. So I'm going to go ahead and try to state the sample space for each of the following experiments that I would do with this spinner. So let's take a look at experiment 1, then we'll take a look at the spinner itself. Suppose that you spin the spinner one time and your goal is to just record the color that you spin. What would be our sample space? So let's take a look at this. So here's a spinner that I can use, and you can see that it has 6 different sections on it. And every time I click the spin button, my little black spinner spins around and it lands in a particular color. Right? And every time I do this, it might change which color it lands in. Okay, but I can see that I have all these different colors. So when I think about what colors might I be able to spin, well, it seems pretty obvious. I have like a gray, a pink, a blue, a red, an orange, a green. And yeah, those are actually all the things that are listed out over here on the screen. So this is my sample space. Those are the only colors that I can actually get. So if I was to go and write my sample space down here, oops, I'll write it in black, but it's going to look like this. It's just going to be S stands for my sample space, and I often just write down all of my different possible outcomes in like a set of curly braces. Let's see, I had pink, blue, red, let's see, there was a green, there was an orange, and there was a gray. So that's it. I had 6 different possible outcomes. That's my sample space. Now notice, even though I'm going to work with the same spinner in experiment number 2, I'm going to change what I'm interested in actually counting or measuring. I'm going to spin the spinner now 10 total times, and I'm going to record how many times the color blue was obtained. Okay, so if I go back to the spinner, I can see I've already spun it here 3 times. And so if I spin it 7 more times all at once here, it'll go ahead and give me a bunch of added results. And so notice that right now I could easily figure out in 10 spins how many times did I get the color blue. Well, this time I got it once. But if I'm going to write down the sample space, I want to know what would be all of the different possible values that I could have gotten right here for how many times blue was landed on. Certainly 1 is a possibility, but there are a lot of different possibilities here. In fact, I could start as low as the value of 0. Maybe I spin the spinner 10 times and I never get a blue. I could get it 1 time, and I guess I could pretty much keep repeating this increase of 1 all the way up until, well, let's see, the max number of times that I could ever get a blue, I guess, would be 10 times, right? All 10 spins, maybe I land on blue 10 times in a row. It could happen like that. So this is the idea of what we refer to as a sample space. And each one of the individual items within the sample space is what we call an outcome.